1. Introduction to nuclear bombs. A nuclear bomb is a weapon that derives its destructive power from nuclear reactions, either fission or a combination of fission and fusion. These reactions release immense amounts of energy, resulting in catastrophic effects that impact human life, infrastructure, and the environment. 2. Key components and materials. Nuclear bombs rely on fissile materials such as uranium-235, enriched uranium used in fission bombs; plutonium-239, created in nuclear reactors and used in implosion-type bombs; deuterium and tritium, used in thermonuclear fusion weapons. Supporting technologies include high explosive lenses, used to compress fissile material in implosion bombs; neutron initiators, start the chain reaction. 3. Nuclear chain reactions. The energy release comes from chain reactions where neutrons split nuclei, releasing more neutrons and energy. The key equation is Einstein's energy-mass relation, where energy released, mass defect from nuclear reactions, speed of light, (310 to the power of 8 meters per second). In fission reactions, isotopes like U-235 absorb a neutron, become unstable, and split into smaller nuclei, releasing energy and additional neutrons. 4. Effects of a nuclear bomb. The effects of a nuclear explosion can be categorized into several destructive forces. A. Blast wave pressure and wind. The explosion generates shockwaves, destroying buildings and infrastructure. Range. Several kilometers from ground zero, with intensity decreasing with distance. B. Thermal radiation. Heat. Extreme temperatures cause fires, burns, and ignite flammable materials. Flash burns. Direct exposure can cause severe skin burns and blindness. C. Ionizing radiation. Initial radiation, high-energy gamma rays and neutrons released within seconds. Fallout. Radioactive debris carried by wind, causing long-term contamination. D. Electromagnetic pulse, EMP. High-altitude detonations create EMPs, damaging electronic systems over wide areas. 5. Environmental impacts. Nuclear detonations have devastating effects on the environment. A. Nuclear fallout. Radioactive particles contaminate air, soil, and water. Fallout spreads globally, depending on wind patterns and altitude of detonation. B. Climatic effects. Nuclear winter. Massive soot and debris from firestorms block sunlight, cooling the earth. Impact on agriculture and ecosystems due to reduced sunlight and lower temperatures. C. Health hazards. Increased cancer rates from radiation exposure. Genetic mutations in affected populations. 6. Mining and production risks. The production of fissile materials involves A. Mining hazards. Uranium mining, environmental degradation, groundwater contamination, and worker health risks from radiation exposure. B. Nuclear reactor hazards. Accidents during the production of plutonium-239 can lead to severe contamination, e.g., Chernobyl. C. Proliferation risks. Theft or misuse of fissile materials increases the risk of nuclear terrorism. 7. Risk mitigation and safety measures. A. International treaties. Nuclear Non-Proliferation Treaty, NPT, prevents the spread of nuclear weapons. Comprehensive Nuclear Test Ban Treaty, CTBT, bans nuclear explosions. B. Monitoring and verification. Satellite imaging and radiation detectors monitor nuclear activities worldwide. C. Environmental restoration. Cleanup and containment of radioactive materials in affected areas. 8. Ethical and societal considerations. A. Moral implications. Debate on the ethical use of nuclear weapons, especially in conflicts. B. Global impact. Long-term geopolitical tensions and humanitarian crises. 9. Conclusion. Nuclear weapons represent a complex intersection of science, technology, and policy. Their devastating effects on humanity and the environment necessitate continued efforts in disarmament,